Well, we meet again. Hello, guys. Welcome to another remote lesson with Miss Pitt. If you haven't done your retrieval quiz, please make sure you've completed that by highlighting the answer for the question. So you've got your question, your multiple choice answer. You need to highlight your answer. If you have done it, move on with the video. If you haven't, pause it, go and complete it. Okay, so the answers for the retrieval quiz are as follows. The type of energy given out by a hydrogen fuel cell is electrical. In a hydrogen fuel cell, we react hydrogen with oxygen. The product formed is water. If they are rechargeable, it means they can be reused. If we connect two or more cells, we are making a battery. Another word for potential difference is voltage. We use metal or graphite to make electrodes. In an exothermic, heat energy is given out. The heat energy exits the reaction, exothermic. And in an endothermic reaction, the temperature decreases because the heat energy is taken in. And combustion is a type of exothermic reaction because it gives heat out. So today we have come to the end of the topic of energy changes. So we are reviewing that topic. So we need to develop and secure our understanding of the energy changes topic. Now, two keywords I've included today are two keywords that I've noticed quite a few of you are still getting muddled up. So two types of reaction, exothermic, endothermic. Thermic referring to heat, exo to give heat out. Exothermic, a reaction that releases heat energy. Endothermic, a reaction that takes in heat energy from the surroundings. So just a quick overview of the topic. We've got the 4 lessons that we've completed. The last lesson we looked at fuel cells, and the lesson before that was chemical cells. Now, the first 2 lessons I've noticed are our weakest areas, so we are going to be recovering that content today and revising it to make sure that we understand the difference between endothermic and exothermic reactions. So, during chemical reactions, there's always energy changes throughout the reaction. In order for a chemical reaction to take place, remember, the particles that are reacting must collide. Now, when they must collide with enough energy. If they don't hit with enough energy, they won't react. So we say that energy is the activation energy, the energy needed for the reaction to begin. So particles must collide with enough energy. That energy is called activation energy. It activates the reaction. It starts the reaction. Now, the reason we need this activation energy to begin with is because in chemical reactions, we know that bonds are broken and new bonds are formed. And we've looked at that example in terms of how a water molecule forms from hydrogen and oxygen gas. If we look here, the reactants, if we look here, the reactants, hydrogen and oxygen, goes to make a water molecule. So these bonds are broken in order for new bonds to form. Now, chemical reactions we know can be classified either as exo or endothermic. So if a reaction is classified as exothermic, it's where heat energy is given out. So a reaction takes place and the heat energy from that reaction is given out, which means the temperature of your surroundings increase. It begins to feel hotter. So for example, combustion, is an exothermic reaction because when it reacts, it gives out a lot of heat energy. And we can test that using a thermometer, and if we see the temperature rise, we know it's exothermic. And exothermic happens when bonds are formed. So when new bonds are formed, when new bonds form between atoms, it actually releases energy. But the main thing I want you to know is exothermic gives out heat. Endothermic is reactions that take in heat energy. Okay, so reactions, they take in heat energy from the surroundings, and therefore the temperature of the surroundings drop. It feels colder. So for example, if ever you've used a cool pack to help with a sports injury, for example, you'll notice that there's a bit of metal that you click inside. As soon as you click that piece of metal, it begins to instantly feel cold. So that is an example of an endothermic. So endo, I think of indo, and the energy is being taken in. The temperature drops. And this happens when bonds are being broken. Think about it. To break something, you need energy to break it. So, for example, if you were snapping a pencil, don't do it, but if you were snapping a pencil, you would need to put in energy to break that pencil. So, breaking bonds takes in energy, therefore, it is endothermic. Now, the second lesson of this topic was about reaction profiles. Now, reaction profiles is a visual diagram that shows the energy changes during a reaction. And it shows us if a reaction is exo or endothermic. Now, we did label these diagrams, so think about it. Which one do you think shows the reactants? A, B, C, or D? Which part shows the activation energy, the energy needed to start the reaction? And which shows the product, the energy left in the products? So let's look. We've got energy on the y-axis. So that's the energy change through the reaction. Along the x-axis, we've got reaction progress, so the progression of the reaction. So as this x-axis goes along, the reaction starts, and then as it goes along, it finishes at the end. And you can see how the energy changes throughout the reaction. So A shows us the energy in the reactants. B shows us the activation energy. So that curve, the top of the curve on the graph, always shows us the activation energy, the energy needed to start the reaction. C shows us the overall energy change. So if you can see the difference between A and C, that's the overall change in the reaction. And D shows us the energy left in the products at the end of the reaction. So you can see that the reactants in this diagram are higher than the products. So the reactants have more energy, therefore the reactants must have given out energy. If the reactants gave out energy, do you think this shows exo or endothermic? Sorry. Exo or endothermic? Good, it's given out heat energy, therefore it must be exothermic. So if a reaction is exothermic, the reactants are higher on the energy graph than the products. And that's how I know, looking at that reaction profile, that is an exothermic reaction because energy has been given out. I know it's been given out because the products end up with less energy. Therefore, energy is being released to the surroundings. So if you're looking at a reaction profile, if the reactants are higher on the graph than the products, it is an exothermic reaction. With an endothermic reaction, where the heat energy is taken in, the products end up with more energy, and therefore the reactants are lower on the reaction profile graph, So you can see the reactants at the bottom here, and the products are higher because energy has been taken in. Therefore, the products end up with more energy, and this reaction profile therefore shows endothermic reactions because energy is taken in. Okay, so your first task, I want you to match the keyword and the definition. So on your student worksheet, you've got the definitions written out. You need to write the keyword next to each definition. Pause the video, go and complete it, come back for the answers. Okay, so the answers are as follows. Activation energy is the energy needed to start a chemical reaction. Exothermic is a chemical reaction that gives out heat energy. Endo is a chemical reaction that takes in heat energy, and a reaction profile is a visual diagram that shows the energy change in a chemical reaction. So that takes us on to task 2, which is an exam style question. So it says, compare exo and endothermic reactions. In your answer, explain the differences between exo and endothermic reactions and give examples of each. So the question's asking you, what's the difference between exo and endothermic reactions? Talk about the difference between the heat energy. One gives out heat energy, one takes it in. One makes your surroundings feel hotter, the temperature increase. One makes the temperature decrease. So I'll just share a model answer with you. So a model answer would look similar to this. You can do bullet points. You don't need to write in a continuous paragraph. So it says, exothermic reactions give out heat energy. This causes an increase in temperature. Some examples of exothermic reactions are combustion and neutralization. Endothermic reactions absorb energy, so they take heat energy in. This causes a decrease in temperature. Some examples of endothermic reactions are photosynthesis and thermodecomposition. So what I'd like you to do is go and complete this task on your student worksheet. Remember, you've out of 6 marks, so try and do roughly around about 6 bullet points. Okay, so compare them, which one gives out heat, which one takes heat energy in, and then give examples. Pause me and come back after you finish your task. Okay, so green pens, remember to be adding in incorrect answers or answers you didn't have, and ticking the ones that you did have. Change your font color to green. So each one of these bullet points is worth a mark. Okay, that leads us on to our consolidation phase for the lesson. So you need to complete the Seneca tasks that have been assigned to you. You need to follow the link that's on your student worksheet. That will take you to Seneca. You need to log in and you will then see the assigned tasks. Now, if you have forgotten your password, I don't know your password. I can't reset it. Only you can do that. So when you log in or try to log in, you need to click the link that says forgot password, and that will then allow you to set a new one. So if you click that link, forgot password, it takes you to your school, it will send you a school email. You then need to follow the link in the school email to set yourself a new one. Thank you for taking the time to access your work. This is the last chemistry lesson for this week. So after Friday, guys, have a really lovely half term and a well-deserved rest.